Can you please give better explanation of I'm not able to get the question. What actually you mean?
Okay, so what I basically mean is that I wanted to kind of explain you guys the term of choke point. Okay, choke point, and choke point is actually what it means is that I'll just write it down. Choke point actually means if a single component failure that will fail the whole system. Okay, so here the person has taken that into consideration in this system design, that okay, there will be like one web server might fail, so that's why there are multiple replicated web servers in Excel. And the thing is that the person has also kind of added a load balancer in Excel, so that the load is kind of served in a regular in a balanced way to all the server. So the choke, so what the choke point mean is that a single component failure, it will fail the whole system. So what is the choke point in this diagram?
Sir, if load balancer get its failure, load balancer get failed, the initial request, that session will not be returned to the client. That will be,
so that's
because they don't have an alternative load balancer, right? They have only one load balancer.
Correct. So that's the actual correct answer. So here the choke point is that the load balancer itself. Okay. So even though the person has kind of thought of like choke point and they have replicated the web server, but they forgot that the load balancer itself can get down, right? It can get down by itself. And what will happen is that no one will be able to then access the web server itself. No matter how there are hundreds of web servers, they won't be able to do that. So what will happen is that definitely as a developer, they need to kind of implement multiple load balancers too. So even if that suppose at least one load balancer, so it's suppose this one goes down, automatically the data is being served from here, and then it loads the data from here, at least one. Okay, so that's how we can avoid the choke point. Now, as a security professional, how we can use this choke point to our benefit? Okay, so this is again something I understood, and I have been utilizing this from the last few years in while handling an incident. So thing is that, let's say there has been, so this is the, let's say this is system design, and thing is that let's say the attacker is trying to kind of access certain components from here to here. Okay, so I will be utilizing this choke point component definition in a way that is helpful to me. So here I understand the choke point is this load balancer. So what I know now, that being a security professional, if I implement a certain kind of mechanism, let's say the load balancer has inbuilt web application firewall. Okay, web application firewall, for example. So I know that this load balancer, or let's say, for an example, okay, so let's say there is a web application firewall in Excel, WAF. Okay, so thing is that now the data is going like this, then it is going like this, and then it is going like this all. So as a cybersecurity professional, I will know now that the choke point is this one and the choke point is this one. So from the log perspective, definitely we will get the logs directly from one system. We don't need to jump on and kind of figure out the different log file, because there's no other load balancer. So if we are able to just get the logs from here, we are getting the complete logs. If we are getting the logs from here, we're getting the complete logs. The reason is that these are the choke point of system design. The other thing is that if we want to kind of stop attacker from kind of making a certain bad request to the servers and all over here, we know the choke point is this web application firewall. There is no other, there's only one single instance, for example. So what we'll do is that we'll add a mechanism only to this point, such that attacker is not able to kind of initiate any kind of malicious request. So what we do over here is that we use a choke point as a cybersecurity person. We use a choke point concept as a benefit for us. Okay, so the developer will think that as a failure point, where we will use that as a successful point. So what we will do is that we know now that, okay, this is one of choke point for us. What we'll do that we will kind of set up certain kind of mechanism over here, maybe certain kind of detections or something like that, or certain kind of blocking, by which the attacker will not be able to kind of send out malicious requests to the server itself, and we will be kind of free from the attack. Okay, at that moment of time. Okay, so this is how we can kind of utilize the system design. We can utilize the concept of system design to handle the investigation in different kind of forms. So now if we know all these things, we know, okay, where we will kind of get the locks, where are the choke points that we can utilize to kind of things going forward. Now how we can stop the attacker by letting the choke points. We'll also know about databases and all, and we also know that, okay, the database replication is always there. So as a security professional, we will be able to read the mind of the developer, what all things the developer team has done. Even though they are not sharing that with us, we can raise those questions. So this is one of the questions that, as I told, one of the scenario where the zero-day attack and no one asked that question. Not even the developer told us that there's a replication in place. And the only way I was able to do that because I did a system design course earlier on that. Okay, so this is not just for developer; it is also for the cybersecurity personnel. So I will pick up, if time permits, maybe I'll pick up one use case, one study case of system design for, let's say, WhatsApp, or maybe an easy one, maybe of the Netflix, for an example, or Twitter. I will share that out. And then you see that, okay, there are multiple authentication also in place, like single SSO authentication, and then OAuth is also there, containers are also there. So you know, like, okay, what all things will be compromised, what all. So whenever we are kind of dealing with any major incident, let's say we are handling the incident of Twitter, the first thing we also wanted to know, okay, what are the authentication in place? And by the authentication, I mean is that most of the time I ask the service team, the team, is that what kind of authentication is in place? Are those authentication multi-factor authentication or just single factor authentication? So those all things we need to ask the service team, and we can only do that once we know, okay, what are the components of a very big software that is in action. So let's say there are multiple incidents where what will happen is that, which I have also handled, is that we were handling one of the software got compromised, and one of the portal got compromised. And when we looked at the authentication, the first thing we asked is that what is the authentication in place? They said that, okay, it's a one-factor authentication. So we know that, okay, this is a very kind of a strict kind of authentication that they have kind of placed in the environment. So even if we are, and even the we also asked the team, like, what's the password complexity? They said like it's of 8 characters and mix of numbers and digits. So we know now that, okay, anyone can kind of just compromise the system. The whole system, the design of the whole system itself, like, not good. And even though this time we are able to kind of contain the incident, the next time attacker will be able to easily able to kind of get hold of the whole system. Okay, because system design has not been kind of proper. So that's where what we did is that we recommended the service team to implement the multi-factor authentication as soon as possible. So to make the system design more secure. Okay. And then if you see, like, these are things we'll obviously look at later, like SSL and TLS. So as a developer also, the guys needs to know that what are the basic encryptions in place. And as a cybersecurity professional, we know that, okay, the SSL and TLS are in action, but we need to ask the service team that, okay, SSL and TLS are in action, what kind of versions they are using. Are they using the version 1, which is like easy to kind of decrypt, or are they using the latest versions? So these are all things we need to kind of figure out when we are doing a massive investigation. And the system design definitely will kind of be a very, 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 very helpful thing for you guys. Because the thing is that when you will be kind of handling any incident where you need to kind of interact with multiple developers, this will also add a confidence to the things that you are kind of talking to the developers. It will add a confidence to you. So you will know basically that, like, the term, like, what happens is the developer use a lot of junk words, okay, which will not make a sense to us. Like, let's say we don't know what CDN, for example, it will not make a sense to us as cybersecurity person. So once we know that, we will be kind of confidently able to kind of traverse or communicate with them and look at all the components of the system and make sure that the attacker is not anywhere in the system. So let's say one of the system design component is rate limiting. So thing is that I actually I think 2 weeks before I handled the incident where I had to ask the service team that one of the things that they forgot is that they had all these things in place. Okay, all the point that is mentioned over here, they had all this thing in place. But the only thing that they missed is that they didn't put this part, the rate limiting part. They forgot about this part in the system design. So what was happening is that the attacker was able to kind of brute force